Everyone, we have the partition chromatography here in the second video. Paper chromatography is a type of partition chromatography, and chromatography paper contains water trapped in it which act as a stationary phase, and so the solvent acts as a mobile phase, and solvent rises up by the capillary action. The paper strip so developed is called chromatogram. The spots of the separated colored compounds are visible at different height from the position of the initial spots in the chromatogram. And paper chromatography diagram is shown in two different shapes. So next thing we have is the spot on the chromatogram. The spot of the separated colorless compounds may be observed either under the UV rays or under the appropriate spray reagents. Next is the qualitative analysis of the organic compounds. In this we have first topic is the detection of hydrogen and carbon. Carbon and hydrogen they're detected by heating the compound with copper 2 oxide, and carbon present in the compound is oxidized to CO2, which is tested with the lime water and it develops turbidity, and hydrogen, which is tested with anhydrous copper sulfate and which turns blue. Okay, so it turns blue with hydrogen. C plus CuO forms Cu plus CO2, and 2H plus CuO gives Cu plus H2O. CO2 plus CaOH2 twice gives CaCO3 plus H2O. 5H2O plus CuSO4 gives H2SO4 dot 5H2O, which is blue in color, and anhydrous copper sulfate, which is blue in color. Next thing we have is detection of other elements. So detection of other elements. The other elements are nitrogen, sulfur, halogen, phosphorus, NSP and halogen. NSP and halogen, which are detected by Lessane test. And in this covalent form, uh, co- co- in this compounds are converted from covalent form to ionic form. This was asked in 2026. And next, by fusing the compounds with sodium metal, and the reactions that takes place are here: Na, which is sodium plus carbon plus nitrogen, which is NaCN, and 2Na plus S gives Na2S, not NaS2, Na2S, and Na plus halogen forms NaX. X can be chlorine, bromine, iodine, not fluorine. Okay, so next thing is carbon, nitrogen, sulfur and halogen come from organic compound. Carbon, nitrogen, sulfur and halogen come from organic compound. And here cyanide, sulfide, halide of the sodium so formed on sodium fusion are extracted from the fused masses by boiling it with the distilled water, and this extract is known as sodium fusion extract, sodium sulfide halide. And these are extracted by boiling with distilled water, and the extract is known as sodium fusion extract. Next thing is test for nitrogen. The sodium fusion extract boiled with ferrous 2 sulfate and then acidified with concentrated sulfuric acid. The sodium fusion extract is boiled with Fe2. It is boiled with Fe plus 2 and then acidified with concentrated sulfuric acid, and the formation of the Persian blue confirms the presence of nitrogen. The formation of the Persian blue color confirms the presence of nitrogen. You can look at the reaction. So the sodium cyanide react with F with the sodium cyanide first react with the iron 2 sulfate and then forms the sodium hexacyanidopherrate twice. On heating with the sulfuric acid, some iron are oxidized to iron 3 ion, which react with the sodium hexacyanidopherrate to produce to produce the iron 3 hexacyanodoferrate, which is the ferriferrocyanide. And you have to remember that Persian blue colored complex, which is Fe4 FeCN6 thrice dot XH2, and rest and its color also Persian blue, and it detects the presence of nitrogen. Next we have test for sulfur. Test for sulfur is like A and B. A is the sodium fusion extract is acidified with the acetic acid, and then lead acetate is added to it. A black precipitate of lead sulfate PVS indicates the presence of sulfur. On treating with the sodium extract, the sodium nitroprusside appearance of violet color indicates the presence of sulfur. Okay, sulfur plus the FeCN5NO 2 minus, it gives FeCN5NOS 4 minus, which is violet in color. 4 minus, okay. FeCN5NOS 4 minus, which is violet in color. And in case both nitrogen and sulfur both are present in the organic compound, so sodium thiocyanate is formed. It gives red blood color and no Persian blue, since there is no free cyanide ions. So the reaction goes Na plus C plus nitrogen plus sulfur S, it forms NaSCN. Fe3 plus SCN minus forms FeSCN plus 2, which is the blood red color. And if sodium fusion is carried out with excess of the sodium, then cyanide is decomposed to sulfide and cyanide, and the ions gives their usual test. NaCN is formed and Na2S is formed. So Na2S is formed. Next is test for halogen. In this we can see that the sodium fusion extract is acidified with nitric acid and then treated with silver nitrate. A white PPT is formed, which is soluble in ammonium hydroxide, and it shows the presence of chlorine. Yellowish PPT, sparingly soluble in ammonium hydroxide, shows bromine, and a yellow PPT, and insoluble it shows iodine. So white PPT and soluble shows the presence of chlorine, white PPT and soluble chlorine, yellowish PPT and sparingly soluble it shows bromine, and yellow PPT and insoluble it shows iodine. So if nitrogen or sulfur are present in a compound, the sodium fusion extract is first boiled with concentrated nitric acid to decompose the cyanide and sulfide of the sodium formed during the Lessane test, and this ion or otherwise interfere with the silver nitrate test for halogens. It is given here. Next is test for phosphorus. And the compound is heated with oxidizing agent, which is sodium peroxide, and then phosphorus is present in the compound is oxidized to phosphate. Phosphorus present in the compound is oxidized to phosphorus to phosphate, and the solution is boiled with nitric acid and then treated with ammonium molybdate. Yellow PPT formed indicates the presence of phosphorus, and ammonium phosphomolybdate formalize NH4 thrice PO4.12MOO3. NH4 thrice PO4.12MOO3, it is ammonium phosphomolybdate. Compound is heated with sodium peroxide first, and then this is formed, and yellow color PPT indicates the presence of phosphorus.